Today's session is about formation of partial differential equation by elimination of arbitrary functions. Approach. Check number of arbitrary functions. If number of arbitrary functions is equal to 1, then partial differential equation of first order is obtained. If number of arbitrary function is equal to 2, then partial differential equation of order greater than 1 is obtained. First, we have to differentiate it with respect to x and y, and if number of arbitrary functions are 2, then we have to differentiate the obtained equation again. Substitute the value of arbitrary function to get required partial differential equation. Let's see one example. Here in this example, we have function of this one function is given. This f can be function, any function. It is unknown function here. So number of arbitrary function here in this example is 1. So when there is one arbitrary function, we get a partial differential equation of order 1. Let p be this and q be this. Differentiation of this with respect to x, we get z becomes dou z by dou x. This f becomes f dash. This term we have to write as such and then differentiate the term inside the bracket following the chain rule. So x square becomes 2x. This y square becomes 0 because we are differentiating with respect to x. And simplifying this, we get this is p. So p is equal to this. This we'll call it as equation 2. Now partial differentiation of this equation with respect to y. Here z becomes dou z by dou y. F becomes f dash. This term we have to write as such. For following the chain rule, this x square becomes 0 because we are differentiating it with respect to y. This y square becomes 2y. Now put the value of dou z by dou y is equal to q and simplify the equation right. Now we'll call this equation as equation 3. Divide 2 by 3. This 2 and this 2 will get cancelled. This function and this function will get cancelled. So we get p by q is equal to x minus y. Cross multiply it. We get this. Bring this term this side. So we get different um, required partial differential equation is py plus qx is equal to 0. This is the required partial differential equation. In this example, we have y square and we have a function. So first we have to look out how many functions are there. Here only one function is there. So we'll have a partial differential equation of order 1. Let this be p and this be q. Now we have to differentiate this with respect to x. Z becomes zx dou z by dou x. This term y term will become 0 on differentiation with x. That is when we differentiate y square partially with respect to x, this term becomes constant. So differentiation of constant is 0. So we get 0 here. Here 2f, 2 we have tried as such. F becomes f dash. This term inside the bracket first we have tried as such. And then following the chain rule, we have to differentiate each term inside the bracket. 1 by x becomes minus 1 by x square when differentiated with respect to x. Log x will become 0. Now this is p and simplifying this we get this. We call this equation as equation 2. Now partially differentiating this equation with respect to y. This becomes dou z by dou y. Y square becomes 2y. This term we have tried as such and this f becomes f dash and term inside the bracket we have to differentiate it with respect to y. 1 by x becomes 0, log y becomes 1 by y. So simplifying it and putting dou z by dou y as cube, we get this. We'll call this equation 3. Now when we compare 2 and 3, this term and this term is same. But only thing is here 2y is there. So bring this 2y this side. So when we bring 2y this side, we get this. Now divide 2 by 4. So p by q minus 2y, and this we get like this. This term and this term get cancelled. 2 and 2 get cancelled. So we get p by q minus 2y is equal to minus 1 by x square divided by 1 by y. Now take this up and bring this down. So we get minus y is equal to x square. Cross multiplying, we get this. Bring this term this side. So we get this expression, that is px square plus qy is equal to 2y square, and this is our required partial differential equation. Now in this example we have arbitrary constants L, M and N, and here we have arbitrary function this. So when arbitrary function and arbitrary constant both are given, we have to consider only arbitrary function. So here number of arbitrary function is 1. So we'll get first order differential equation. Let P be this, Q be this. Differentiation of this with respect to x. So Lx, differentiation of Lx is L. Differentiation of y is 0, so this full term will become 0. Here n is n, z becomes dou z by dou x. Now this function, this will become dash, and this we have to write it as such. Then differentiate the term inside the function, that inside the bracket. X square becomes 2x. This y square when differentiated with respect to x is 0. Z square becomes 2z, and then again differentiating z becomes dou z by dou x. Now simplifying it, this we have to put dou z by dou x is equal to p, and dou z by dou x here also we have to put it p. So the equation which we get, we can call it as equation 2. Now partially differentiate this equation with respect to y. When we differentiate it with respect to y, this term will become 0, this will become m, and n is there, and z becomes dou z by dou x. This term we have to write as such, but we have to put here dash and then differentiate the term inside the bracket. This term becomes 0 because we are differentiating it with respect to y. Y square becomes 2y, and z square becomes 2z, and then again differentiating z becomes dou z by dou y. Now put the value of dou z by dou y here and here, so it becomes q here and q here. Simplifying the equation, we get this. Now divide equation 2 by equation 3. So we get this. This term and this term get cancelled. So we are left with this and this. Now cross multiply these two. We get this. Then multiply each term and simplify it. We get this. Now here we have 2 throughout, so it will get cancelled. Take 2 common and it will get cancelled. Now here in this term, npqz and npqz here there, so this and this will get cancelled. Now bring all p term here and bring all the q term here, so we get this equation. This is required partial differential equation. In this example, f and g are two arbitrary functions. Here x, t and z are variables, x and t are independent variables, z is dependent variables. So number of arbitrary function 2 is equal to 2, hence we will get second order partial differential equation. Now let's partially differentiate this equation with respect to x. So z becomes dou z by dou x, this f becomes f dash, this term we have to write as such, and then we have to differentiate this with respect to x. Differentiation of x is 1, at. Since we are differentiating t with respect to x, it becomes 0. Plus this g becomes g dash, this term we have to write as such. Then differentiation of this is equal to x will become 1, and differentiation of t with respect to x is 0. So we get this. So this again we have to differentiate with respect to x. So we get dou square z by dou x square is equal to, this f will become f double dash, this term we have to write as such. Differentiation of x is 1 and differentiation of this is 0. Plus this g this g dash will become g double dash. This term we have to write as such, and then differentiate this. X on differentiation becomes 1, 80 on differentiation becomes 0. We get this equation. Now we have to differentiate this equation with respect to t. So we get z will become dou z by dou t. This f become f dash. This term is we have tried as such, and then we have to differentiate this term with respect to t. So um, x becomes 0, t becomes 1, 1 into a is a, plus g will become g double dash. This term we have tried as such, and then this ax on differentiation with respect to t will be 0, and t is 1, 1 into a is a. Now we get this equation. Now we have to again differentiate this equation with respect to t. So we get dou square z by dou t square. Here a is there, we have tried a as such. F dash will become af double dash. We have tried this term as such, and then differentiate this. This when differentiated with respect to t, it becomes 0. This is t into a is a, minus this a we have tried as such. This g will become g double dash, and this we have to write as such, and differentiation of x is x with respect to t is 0, and differentiation of t is 1, 1 into a is a. Now this becomes equation 3. Here a square and a square are common, so we can take a square out and we get this equation. This term is same as this term, so putting 2 in 3 we get this. This is our required partial differential equation, that is dou square z by dou t square is equal to a square times dou square z by dou x square. Here this example is same as the previous one. Here instead of a, here we have I is given. So there a was given, here I is given. The reason I took this example is here we have to follow the same procedure, but here when it comes to I square, we have to just put I square is equal to minus 1. We know the imaginary number of I square is minus 1. So when we get this I square here, we have to put minus 1, and rest all same procedure. So we get this answer. Example, we see f of x and g of x. There are two arbitrary and order partial differential equation. Now let's differentiate this partially with respect to x. Differentiation of z is dou z by dou x, and differentiation of x, this f will becomes f dash, this x is x, and differentiation of x is 1, plus here this term we have to write e to the power y, we have to take it as constant, so we write it here, and g will become g dash, and x we have to write as such, and then differentiate x, we get 1. So we get this equation, which we'll call it as equation 2. Now we'll differentiate this equation partially with respect to y. So z becomes dou z by dou y, and this term, it becomes 0 because differentiation of x with respect to y is 0. So we get this term will become 0, plus here e to the power y, differentiation of e to the power y is different e to the power y, and g of x is constant because here we are differentiating it with respect to y, so we just write g of x. So this is this equation, we'll call it as equation 3. Now again partially differentiating equation 3, that is dou z by dou x is equal to e to the power y g of x with respect to y. We get dou square z by dou y square is equal to this it will be same differentiation of e to the power y with respect to y will be e to the power y, and this g of x will be same, because here y, when we this x, when we differentiate with respect to y, it will be considered as constant. So here constant multiplication rule is used, so we get ey times g of x. So we'll call this equation as equation 5. Now, when we compare equation 3 and 5, we see these two are same. So, equating equation 3 and 5, we get dou z by dou y is equal to dou square z by dou t square. So, this is required partial differential equation.